The existence and uniqueness theorems give conditions on a differential equation that guarantee solutions exist and are unique. But what if these conditions aren't met? Consider the initial value problem, dy dx equals x over y, with y of 1 equals 0. This is a nonlinear differential equation that does not satisfy the conditions of the existence and uniqueness theorem, since the function defining dy dx, namely f of xy equals x over y, is discontinuous at y equals 0, the value of our initial condition. Thus, there is no rectangle around the initial condition x equals 1, y equals 0, where f of xy is continuous. While the theorem does not guarantee the existence nor uniqueness of the solution, we can still explore solutions of this differential equation since it is separable. We can see this is separable by multiplying y to get that y times dy dx is equal to x. And now that it's in this form, we can proceed with finding solutions. Integrating both sides with respect to x gives us that the integral of y dy dx is equal to the integral of x dx, where the right-hand side is x squared over 2 plus a constant c, and the left-hand side can be simplified using the substitution rule as the integral of y dy, which is y squared over 2. And we can solve this for y first by multiplying by 2 on both sides to get that y squared equals x squared plus k, where k is a new constant 2 times c, and then taking the square root of both sides, which yields that y equals plus or minus the square root of x squared plus k. And then at the initial condition, y of 1 equals 0, we get that 0 equals y of 1, which evaluating our functions above is plus or minus the square root of 1 squared plus k. And squaring both sides of this gives us that 1 plus k is 0, and thus k equals negative 1. So both functions, y1 equals the square root of x squared minus 1, and y2 equals negative the square root of x squared minus 1, are solutions to the differential equation, defined for x bigger than 1 and satisfying the initial condition y of 1 equals 0. So in this case, solutions existed despite the conditions of the theorem not being met, but the solution was not unique.